What's going on? I'm Anastasio Dalbe. This is SDG Labs. I am the world's best dad, hands down. I've got a shirt that says so. Alright, here's a concept I want to hit with you on talking about the end behavior of the graph. Why do we care about the end behavior so much? It kind of helps us with an understanding of how the graph looks. And what I mean by end behavior is that whole business about, well, does it or does it start and stop in the same direction? And so what I'm going to do is I set up a little table and I'm just going to calculate out something. I've got x cubed plus 1000x, and what I want to do is for large values of x, I'm going to try out and I want to see which one dominates. Domination. All right. If I plug in x in equals 1 into the x cubed, that would only give me 1 times 1 times 1, which is just 1. And then over here, this would give me 1000. That's plugging in x equals 1. You just take whatever this is, tack on 3 extra zeros. So who's winning? Obviously 1000's winning. All right, let's plug in 10 into here. This would be 10 cubed, which just basically means a 1 with 3 zeros. 1, 2, 3. All right, there we go. And then this would be 10 with 3 extra zeros, so that would be 1, 2, 3. Oh, okay. This guy is 10,000, this guy is 1,000. He's still winning, but by a little bit less of a gap. This is a big gap. This is not as big of a gap. Let's plug in 100. 100 cubed means 100 times 100 times 100. That's 3 pairs of zeros, which means 6 zeros, because this is a pair of zeros, so 3 of them. So I've got 1, 2, 3, 4, 5, 6, a million. Now this would be 100 times 1000, so this would be 100 with 3 more zeros, so that's be 100, 3 more zeros. Oh, wait a second. Who's winning now? This guy's winning, that guy's losing. Or what about over here? This would be 3 sets of 3 zeros, so that's actually just kind of, you just think of this as 1000 cubed is really just 9 zeros altogether. So that would be 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this guy right here, if I multiply 1000 times x, that would just be 1000, 1000. That would be 6 zeros. Who's winning now? This guy's like a billion and this guy's a million. All right, let's do the next one. This would be 4 zeros, but I need 3 groups of them, so that would be 12 zeros. So that would be 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Over here, this would be 4 zeros plus another 3, so that would be 1, 1, 2, 3, 4, 5, 6, 7. I'd rather have this much money than have this much money. So you see that at the beginning, this guy was losing, this guy was winning, but towards the end, as the numbers got really, really big, this guy dominates, this guy loses. And really, all we care about when we're talking about the end behavior of something, what we're trying to figure out is what is this thing going to look like as I get far out to the right or far out to the left? If I'm talking about going far out to the right, I'm talking about using really, really big numbers. And really what I'm asking is it going to be going up at the end or is it going to be going down at the end? Let's take a look at a few. Let's kind of take a look at this one. X cubed. In fact, I'm going to drop the last half of this thing because we saw that when we're talking about the end behavior of things, this thing is the only thing that's important. So for the end behavior, if I have a big number, like let's say 100, is that going to be a positive number or a negative number? So a positive 100 cubed, that's going to be 100 times 100 times 100. It's going to be a positive number. So I know that whatever the graph looks like in the middle, as it gets towards the end, it's going to be starting to go like this. All right, now let's plug in x equals negative 100. What is that graph going to look like? Well, as x equals negative 100, that would be negative 100 times negative 100 times negative 100. All right. If I have a negative times a negative, that makes a positive. So this is positive 1 or 10,000. I still got to multiply that by one other negative. So this would be negative 10,000 with 2 more zeros. What is that? That's a million. Negative a million. So this guy, when he's way out on the left side, he's actually going to be a y value that's really low. So as the graph gets far out to the left side, this graph is going to start ending over here. Now, it could be doing something funky in the middle, and you know that since it's an x cubed term, it's probably going to look something like that. But that fits our criteria. On the far right-hand side, it's going up. On the far left-hand side, he's going down. Which is kind of a good hint as to why degrees that have an odd term start and end in opposite directions. Let's talk about something like x to the 4th power. Because, like I said, I could have x to the 4th power plus 1000x cubed minus 2700 x squared plus, I don't know, a million x minus 4. But at very large x values and at very negative x values, the only term that really dominates this thing will be the x to the 4th power. So when I consider something really big like that, but I'm considering the endpoints specifically, I can I can't erase them. It doesn't go away. But the only ones that are important are the x to the 4th power. Let's talk about what those end behaviors are going to look like. At very, very, very large x cubed term or x's, if I take the 4th power of that, that's going to get extremely large that way. Now at very, very large negative values, like let's say I have negative 400, or let's say I have negative 100 again. I'm going to have to move that to the 4th power. Which basically means multiply it by itself 4 times. This negative times that negative will give me a positive number. This negative times that negative will give me a positive number. And then these two positive numbers multiplied together will also give me a positive number. So even though I'm at x equals negative 100, way out on this left side, I'm going to get a very big positive number because it's 100 times 100 times 100 times 100 positive version of that. So it starts and ends at the same point. Now this concept is pretty simple if I strap down a negative out in front. So if I plugged in a negative over here, that's really just telling me to take all of my answers and flip it upside down. So what this graph is going to do is it's going to start down and it's going to end down. What I mean by start, I don't really mean start. I mean, if you go far to the left, it will end up going down. If you go far to the right, it will end up going down. It could do something funky in the middle. It could be going something like this, like that, but I know that it's at the end points, it's going to be going down and going down, if there's a negative x4 out in front. Now, you'll get this funky pattern if you add on those extra 1000x cubed, million x squared, blah, 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 blah. But really, as far as the end behavior goes, so maybe you don't know what the middle part looks like, but I can tell you for sure that the end behavior is going to look something like that. Shoots, bro, up out.